Alright guys, last lesson here before our test, okay? So here we go. Notice here, it says solving trigonometric equations for values between 0 and 2 pi. On Delta Math and on the test, it'll be written this way, between 0 and 2 pi. Notice how x is in between. So 0 is less than or equal to x, and x is less than or equal to 2 pi. In other words, between 0 and 2 pi. Or as you know it, between 0 and 360 degrees, okay? So these look very complicated, but they're really not. Check this out. So first thing we're going to do is we're going to isolate the cosine term or the trig term. Okay, so it'll be either sine, cosine, or tangent. Okay, so right here, let's go ahead and subtract square root of 2 on both sides. Okay, so those cancel. I end up with 2 times cosine of x equals negative square root of 2. Okay, last step is to divide by 2. So we want to isolate the cosine. So we end up with cosine x equals negative square root of 2 over 2. That's it, right? So what we're trying to find out here is for what values of x is cosine negative radical 2 over 2. So remember, we use our unit circle, right? The cosine is always the x value. So we're going to go around the unit circle and we're going to locate negative radical 2 over 2. So cosine is not negative in the first quadrant. It's negative in the second quadrant. So these are all cosines right here. Okay, so notice here we have a negative radical 2 over 2. That's in the cosine position. In other words, in the x position. So where do we find that? At 3 pi over 4. So 3 pi over 4 is one of the answers. Okay, and let's find the negative radical 2 over 2 in the third quadrant. Notice here we have a cosine right there. So that also counts as an answer. Okay, so negative radical 2 over 2 happens at 5 pi over 4. And those are our answers. Okay, notice how they wanted us to write our answer in radians because they gave us the interval in radians here. So notice here it's between 0 and 2 pi. They didn't say between 0 and 360. So they're not talking about degrees, they're talking about radians. Okay, let's do the next one here. Notice tangent of x is being multiplied by 3, and then the square root of 3 is already on the other side, so we just need to divide by 3 here. So we have tangent of x equals square root of 3 over 3. Okay, remember on the unit circle we used tangent already. We already found tangent. Notice here it's on the outside of the coordinate pairs, right? So here we have radical 3 over 3. That happens at pi over 6. So it happens at pi over 6. We'll have radical 3 over 3. Where else? There's a negative radical 3 over 3. That one does not count. There's another positive radical 3 over 3. Okay, so that one is the other one. So it's 7 pi over 6. Notice if I were to check in the fourth quadrant, I would end up with a negative radical 3 over 3. So that one does not count. Okay, pretty easy. Let's do 4 more. So let's go ahead and add square root of 3 here on both sides. So that cancels out. I have 2 times sine of x equals square root of 3 divided by 2. Those cancel and I end up with sine of x equals square root of 3 over 2. So once you solve, you end up with the unit circle here. You look it up. Square root of 3 over 2. Notice there's a square root of 3 over 2 right there on the sine. We're looking for sine, so this one will work at pi over 3. And then let's see where else is sine. Positive here, radical 3 over 2, right there in the second quadrant. Okay, so notice here at 2 pi over 3. Alright, now let's take a look at the ones with the square, the exponent here. Okay, so basically doing the same thing, except now we have to square root. Okay, so let's go ahead and add 1 to both sides. So we have cosine squared of x equals 1. Okay, now when we square root both sides of an equation, our answer on the right hand side is going to end up plus or minus, positive and negative. Okay, so on this side here, the square will cancel out with the radical. And so we'll be left with cosine of x equals plus or minus the square root of 1. But what's the square root of 1? Well, it's 1. So this is going to be cosine of x equals plus or minus 1. Okay? So now, with our unit circle, we have to locate all the values of x where cosine is 1 or negative 1, right? Because we have a positive or a negative 1. So pretty much here cosine is the x. Notice there's a positive 1 right there. Okay? These are radical 3 over 2, radical 2 over 2, 1/2, and so on. If you go around the circle, you'll end up noticing here at negative 1, right? A negative 1 at pi. And then you go around the circle, there's nothing, there's a negative 1 there, but that's on the sine, not on cosine. So it only happens at cosine of 0 and cosine of pi. Okay? So at 0 and at pi is what we end up with positive 1. The 0 will give us the positive 1, and then the pi will give us the negative 1. Okay? So here's pi, and there's negative 1. Okay? So just keep that in mind. It'll end up with a plus or minus each time. Next one, let's add 1 to both sides. So we have 4 times sine squared of x equals 1 divided by 4. We end up with sine squared x equals 1/4. Okay, and so now we have to square root both sides. That cancels out. Remember the plus or minus. Sine of x equals plus or minus square root of 1 over square root of 4. Okay, I'll just write it like that. Okay, and now notice, let's take the square root of 1, so that's going to be 1 over 2. So plus or minus 1/2. So sine x is equal to plus or minus 1/2. And so on the unit circle, let's look for wherever sine is positive 1/2 or negative 1/2. Okay, so notice here, sine is always the y here. So there's 1/2. It happens at pi over 6. That's positive 1/2, right? Look here, we have another positive 1/2 on the sine. Don't confuse it with this positive 1/2 right here. That's on the cosine, okay? So we're only interested on the y coordinate here, on the y value. So sine is 1/2 right there at 5 pi over 6. Now let's look for negative 1/2. Well, we're going to be on the y, right? Negative 1/2 is right there at 7 pi over 6. Do you start to notice a pattern here? They all have the same denominator, right? Well, where else? Let's see. Let's look at the other 11 pi over 6 here. Notice that there's negative 1/2, which is at 11 pi over 6. Okay, 11 pi over 6. So that's where you will find sine being positive 1/2 or negative 1/2. Okay, so there's 4 of them total. Last one here, let's add 1 to both sides. So we end up with 2 times sine squared of x equals 1 divided by 2. And we end up with sine squared of x equals 1/2. So let's square root now. So those cancel there. I end up with sine x equals plus or minus, and I'm just going to break it up into 2 pieces. Square root of 1 over square root of 2. Okay? Now, the square root of 1 is 1, and the square root of 2, well, remains that way. But remember, we're supposed to rationalize the denominator, which means to get rid of the radical here. So we're going to multiply by radical 2 over radical 2. And that'll give me radical 2 over 2. Because remember, that becomes square root of 4. And what's the square root of 4? It's 2. Okay? So in other words, we're supposed to find all the values of x where sine of that value equals square root of 2 over 2. Again, we're looking on the y. So notice here, there's square root of 2 over 2, so that happens at pi over 4. Oh, and don't forget your plus or minus. I forgot it right there. That should be plus or minus, okay? So I did write it right there. Plus or minus. So it happens, notice here. If it happens here, the sine of 45 or pi over 4, right? Then all the ones that have pi over 4 are going to be the same. So pi over 4. Notice that. There's a radical 2 over 2 right there on the sine. These are negative radical 2 over 2 at 5 pi over 4, and then negative radical 2 over 2 at 7 pi over 4. So at all the pi over 4s, that's where we find a positive radical 2 over 2 or a negative radical 2 over 2. So I'm just going to write it in order. Pi over 4, 3 pi over 4, and then 5 pi over 4, and lastly 7 pi over 4. Okay, that's it.